Hi everyone, today I'm gonna show you two useful data visualization package for complex machine learning models such as support vector machines and random forests. So the dataset I use for this task is California housing prices downloaded from Kaggle website. And here are some basic introduction of the columns. So for the simplicity of this model, I just remove all the rows containing the null value, and here are some basic introduction about the packages I'm gonna use today. So partial dependence plot (PDP) is a visualization tool used to show the average effect of a single feature on predicted outcome of a model. It helps us to understand how changing the value of a particular feature influences the model's prediction, holding other features constant. While ICE individual conditional expectation plot is a more detailed interpretation tool that extends the concept of PDP by showing how individual data points respond to changes in a feature. Unlike PDP, which shows the average effect, ICE plots display a separate line for each observation, but we still have the option to observe the average effect. So for the data pre-processing, I just changed the character variable ocean proximity to factor data. And I also sampled 10,000 or 1,000 rows from the dataset to speed up the model because both modeling and model training and plotting, especially for the ICE plotting, requires a lot of time as ICE needs to print out all the observation in one graph. So I think it's more convenient and efficient for us to make the model more simpler. And after training the random forest, we are ready to print out our graph. So for the PDP, we set the median income as our x-axis, which is an independent variable in this case. So as you can see, the average effect shows that as the median income increase, the predicted median house value also increases. But there's a diminishing return as after 10, there's no more huge increase after that. So the PDP shows us the average effect of the median income on the median house values. And for the ICE, we can have a more detailed view for these changes. So as you can see, ICE shows all the observation in one graph, and the centered black line shows the average effect, which is the same as the PDP. But another thing interesting about ICE is that it also has some interesting parameters to play with. So for example, this one removes all the dots representing actual points. And if we turn this to true, several like points will be added on the graph and make the graph quite messy. So I suggest we always turn this to false. And the second one, plot PDP, which enables us to add the PDP at the center of the ICE graph. And the last two parameters, I think, is quite interesting, which is color by and X quantile. And if we comment this out, um, the first one enables us to project each observation on a factor variable, so ocean proximity in this case. And the second one enables us to change this uh, quantile range. You can see the median income is in quantile in this case. And when we turn this to false, it will change the range of median income to the original value range, which is 0 to 15. So the plots requires a little bit more time, and we can see the difference shortly. So right now you can see for each observation, they are colored in the according to their ocean proximity type, and you can see all the observation, including the PD centered average line, shows the similar distribution, similar changes to the previous PDP plot. And the range is also changed. Besides, another interesting fact I would like to share is that you can see there are several vertical lines here, which represents the quantile range. So I think each Each represents 10% in this case, and you can see most of the data are clustered at the left side. So we can suggest we can say that the data is somehow right skewed. And that's pretty much I would like to share today. Thank you so much.